Let's see this question. In this we have to calculate IT. IT is the current across inductor. And remember, I told you the formula for the current across inductor, that is I of infinity plus I of 0 minus I of infinity e raised to power minus t by tau. For this we need tau, right? For this we need I of 0, and for this we need I of infinity, right? So for I of 0, like we'll follow certain steps. Step number 1, we always calculate the condition at t equal to 0 minus, right? So this is our switch. Tell me, at t equal to 0 minus, switch is closed or opened? Switch is, like, at t equal to 0 it is open, but it is t equal to 0 minus it was closed, right? At t equal to 0, switch is opened, right? And at t equal to 0 plus also switch will remain open. So first we need to draw the condition for t equal to 0 minus, correct? So t equal to 0 minus, switch is closed, so we can draw the circuit, right? And for that we need to calculate the current across inductor. Okay, now suppose the switch is closed. This is the switch and the switch is closed. Now for inductor, from a long time current is flowing through the inductor, so inductor will behave as a short circuit, right? Remember that this was the condition of steady state, right? This is the condition of steady state. In the condition of steady state means from the long time switch is closed, so inductor will behave as a short circuit. If there would be capacitor will behave as a open circuit, correct? So in this case current flowing, that would be I of 0, because at t equal to 0. So we need to calculate I of 0. So we can simply calculate by using mesh analysis. How many meshes are there? Tell me. 3 meshes are there. This one is, we can consider I1, this one we can consider I2, and this one we can consider I3. 3 mesh means 3 variable, and we have to draw 3 equation, right? Can you tell me the first equation which we can make it from directly the current source? I1 is equal to 5 ampere, because I1 and 5 ampere direction is same. I1 is also moving from up to down, and 5 ampere is also moving from up to down, right? Similarly, tell me the equation for the second mesh. Positive, yes, negative 8 I2, then negative 5 I2 minus I3, then negative 12 I2 minus I1 would be equal to 0, right? Similarly, can you tell me the third mesh equation? Minus 5 is equal to 0. Simple, right? So after solving it, we'll get, we should know the value of the current across inductor, right? So the current across inductor would be equal to, tell me, in terms of I1, I2 or I3, because we have calculated I1, I2, I3, right? So this inductor was in the middle wall of I1 and I3, right? I1 direction and inductor direction is same or different? I1 is also moving from up to down, and inductor current is also moving from up to down. So these currents are in the same direction or in the opposite direction? So I1 would be positive and I3 would be negative. So can we say that I0 is equal to I1 minus I3, right? Because we want the current across inductor, and after solving it you will get 2 ampere. Okay, clear? Now for this we got the value of I of 0, right? I of 0 is, we got it as 2 ampere. Next we need to calculate I of infinity, right? Again we'll draw the circuit at t equal to infinity. This is also the condition of steady state, right? So in steady state, again inductor will behave as a open circuit or short circuit. No, again inductor is going to be short circuit only. In steady state condition, inductor will always behave as a short circuit. Okay, so now in this case, at t equal to infinity, switch is opened or closed? Remember, at t equal to 0 plus, switch is open, or at t equal to infinity, switch is opened. So if there is open circuit, there is no role of current source, right? So there is no role of current source now. So I just deleted that current source. Again inductor will behave as a short circuit, correct? So now at this condition I infinity we need to calculate. I infinity is the current across inductor, correct? So can you tell me I infinity is how much? No, is there any source which is providing current? No, na. So I infinity must be how much? Yes, I infinity would be going to be 0, because if no source is present, obviously then no current can flow. So I infinity we got it as 0 ampere. Okay, we can put down the value of here, that is I infinity 0, again this I infinity 0 ampere. Now what is left? Tau. Tau is L by R, right? And remember in the last lecture I told you for calculation of tau. So for calculation of tau, we have to consider circuit at t equal to 0 plus, means the transient condition. Okay, whenever just we switch the change the switch. So when we change the switch at t equal to 0 plus, switch is opened or closed? Opened, right? So I can redraw the diagram. So the if the switch is open, there is no role. Okay, and again in this case, in the transient condition, inductor will behave as a how much? We have to draw our equivalent from this A and B terminal. Okay, we have to calculate our equivalent from these two terminal A and B. Clear? Now can you tell me which resistor is in series and which resistor is in parallel? Like you are at A position and you have to move to B position. All these are your friends. 12, 8, 5 are your friends. If two of your friends are connected in the same path, then they are connected in series. if two of your friends are connected in the different path, then they are connected in parallel. Okay, now just start moving from A. Tell me, 12 and 8 are at the same path or at the different path? Same, so that would be 12 plus 8, right? That would become 20 ohm, right? If I'll redraw the circuit, that will become 20 ohm, that is 5 ohm already, and now this is B, this is A. Again we are at the A position, we have to move towards B. Now tell me, 20 and 5 are in series or in parallel? They are in parallel. So R equivalent would be 20 parallel 5. 20 parallel 5 is 4 ohm, right? But what we need to calculate? Tau. Tau is L equivalent by R equivalent. L we already know, that is mentioned in the question, 2 Henry, right? 2 divided by R equivalent we calculated, that is 4 ohm. That would be 1 by 2, that is 0.5 second, correct? Now we can put this value in the standard form of equation, right? I'm writing those. This is the formula, okay? You need to remember it. I'm writing it again. IT is equal to I of infinity plus I of 0 minus I of infinity e raised power minus t by tau. Okay, I infinity we already calculated. What was that? At t equal to infinity, current across inductor is 0. So we can put here that I infinity is 0, right? Now at I0 means at t equal to 0 minus, right? We calculated current across inductor, that was 2 ampere, right? So we can put 2. Now e raised power minus t by tau also we calculated, that is 0.5 second. So that would be 0.5. Okay. Now 2 into e raised power, if I'll solve it, then that would be minus 2t ampere. This is our final answer for the current across inductor at time t. Understood? Now suppose in this question only they would have asked that you have to calculate voltage across inductor also, again for time t is greater than 0. So now can you tell me how can we calculate the voltage across inductor? I is no, I we already know. We need to calculate voltage across inductor in the form of equation only. Remember I told you the formula? Tell me the formula. VL is equal to, yes, L di over dt. L we know, 2 d by dt of I we already calculated, that is I of t, 2 into e raised power minus 2t, right? So 2 is constant, we can take it outside, that would become 4. E raised power minus 2t differentiation is into minus 2 and e raised power minus 2t. So that would be the voltage across inductor. Okay, remember I told you that in inductor we always calculate current. If they ask us the voltage, then we can use this formula. Okay, but in capacitor we always calculate voltage, but they ask, sorry, but they ask current. So IC is equal to, what would be the formula? You can calculate it, calculate current across capacitor by using the formula only. Okay, that is C dv by dt. Simple, clear? And current across inductor would be same at every time, and the voltage across capacitor would be same, Vc0 minus equal to Vc0 plus.